Hey folks, how does an AI agent remember what it did yesterday? Most agents start with a simple working memory, the context window. This scratchpad holds the current conversation and recent tool outputs. When the agent receives a message, it writes the context into working memory and reads previous context back. This read write cycle is the heartbeat of the agent's operation, but this memory is volatile, it disappears when the session ends. That makes it fast but ephemeral. The context window has a fixed size, typically measured in tokens. For many models, this is around 8,000 tokens. Working memory is the first building block, that's the immediate memory. But agents also need to remember past interactions. So we add episodic memory, a store of past experiences. The agent captures sequences of events, what it did and what happened. Every time the agent answers a query or takes an action, it stores that episode. When faced with a new request, the agent recalls similar past contexts from the episodic store. The agent uses the retrieved episode to inform its decision, improving accuracy over time. Now, the agent can learn from history, but what about general knowledge it should recall without having experienced? Next, semantic memory, the agent's long term knowledge base. This is where the agent stores factual knowledge like document embeddings and rules. When the agent needs a fact, it queries the semantic store. The store returns the relevant data. New information updates the semantic store. The agent stores updated embeddings to keep knowledge current. Now we have three memories, but all of them need to forget. That's where eviction policies come in. Each memory type needs an eviction policy. Without it, stores grow unbounded. Working memory uses a sliding window. Oldest tokens drop when capacity is reached. Episodic memory uses time to live and least recently used eviction. Old or rarely accessed episodes are removed. The agent stores an episode, then later retrieves it. But if it's too old or not used, it gets evicted. Semantic memory uses importance based eviction. Frequently queried facts are retained, while rarely accessed ones are pruned. With eviction policies active, each memory manages its size and retains only what matters. Working memory keeps recent context, episodic preserves important episodes, and semantic stores frequently accessed facts. Together, they form a balanced memory system. Eviction keeps the system healthy. Now, let's see these three memories work together in a real request. Let's trace a single request through the full memory architecture. A user asks a follow up question, so the agent first checks working memory for recent context. Working memory returns any relevant conversation history. Then the agent searches episodic memory for similar past interactions. Episodic memory retrieves relevant episodes. Meanwhile, eviction policies remove stale data from working and episodic stores. Finally, the agent queries semantic memory for factual grounding. It retrieves the stored knowledge. That's how the agent retrieves, stores, and forgets a complete memory lifecycle. To recap, agents start with working memory for immediate context, add episodic memory for past experiences, and semantic memory for factual knowledge. Eviction policies keep each store bounded. The result is an agent that remembers what matters and forgets what doesn't. And that's the breakdown. Subscribe to this channel for AI updates. Catch you in the next one.